June the 13th, 1944, 7 days after the most successful amphibious invasion in history, the American advance through Normandy had ground to a complete halt. Not because of German counterattacks, not because of lack of supplies or air support. The Allied armies, having crossed an ocean and stormed fortified beaches, found themselves stopped by something far older and more stubborn than Hitler's Atlantic Wall. They were being defeated by hedgerows. The bocage country of Normandy stretched inland from the invasion beaches like a vast natural fortress that neither Allied planners nor intelligence officers had properly understood. For over 1,000 years, Norman farmers had divided their fields with living walls of earth, stone, and vegetation. Each field was bordered by an earthen mound 3 to 4 feet high and 6 to 8 feet thick at the base, crowned with centuries-old hedges of hawthorn, brambles, and small trees that grew another 6 to 12 feet above the embankment. The roots of these hedges, growing for generations, had woven the earth and stone into something approaching concrete hardness. What resulted was not farmland as the Americans understood it. The bocage was a labyrinth of small, irregular fields, none larger than a few acres, each enclosed by impenetrable walls of earth and vegetation. The fields were connected by narrow, sunken lanes, worn down over centuries, until their surfaces lay 10 feet below the level of the adjacent fields, creating ready-made trenches. From the air, Normandy looked like pastoral countryside. At ground level, it was a defender's paradise and an attacker's nightmare. The German commanders recognized the tactical gift they had been handed. Each hedgerow-enclosed field became a fortified position. Machine gun teams could set up in the corners where hedgerows met, with clear fields of fire across the small fields. Mortar teams could position themselves behind the next hedgerow, invisible to attackers. Snipers could hide in the thick growth atop the embankments. Panzerfaust teams could wait in the lanes, knowing Allied tanks would have to funnel through predictable choke points. The mathematics of the bocage were devastating. Between the invasion beaches and the town of St. Lo, less than 20 miles inland, there were approximately 3,500 individual hedgerow-enclosed fields. Taking each field meant approaching across open ground under observation and fire, reaching the hedgerow, breaching or crossing it under fire, clearing the enclosed space in close combat, then repeating the process for the next field. American divisions that should have been advancing miles per day were instead measuring progress in fields per day. Sometimes in fields per week, American infantry learned quickly that crossing a hedgerow on foot was close to suicidal. The German defenders had only to wait until attackers were silhouetted against the skyline at the top of the embankment, then open fire at point-blank range. Casualties were horrific. Entire squads would be cut down in seconds. The psychological toll was crushing. Every hedge crossing required individual acts of courage that, repeated dozens of times per day, exhausted even the bravest men. The tanks? The armored fist that was supposed to punch through German defenses fared no better. When a Sherman tank approached a hedgerow at speed and attempted to climb it, the tank's nose would rise up the earthen slope. As the tank crested the top of the embankment, its entire vulnerable underbelly would be exposed, the thinnest armor on the vehicle tilted upward toward the sky. At that moment, the tank's own guns were pointing uselessly upward. The tank crew was helpless. A German soldier with a Panzerfaust anti-tank rocket, or even a well-placed artillery shell, could penetrate the thin belly armor and turn the Sherman into a funeral pyre for its 5-man crew. Tank commanders tried everything. They attempted to go around the hedgerows, but the fields were too small and the lanes too narrow. They tried to smash through the hedgerows by charging them at full speed, but the centuries-old root systems and earth embankments were too strong. The tanks would become stuck, engine straining, tracks spinning, accomplishing nothing except to present a stationary target. Some tankers tried using their main guns to blast holes through the hedgerows, but the 75mm high explosive shells simply detonated against the earth and vegetation without creating a passage wide enough for a tank. combat engineers attempted to solve the problem with explosives. Teams would dash across open ground carrying Bangalore torpedoes and satchel charges to the base of a hedgerow, plant the explosives, light the fuses, and run. The resulting explosion would blow a gap through the hedgerow, and tanks would rush through. But the explosion was like a beacon announcing exactly where the attack was coming. German defenders knew precisely where to concentrate their fire. The method worked, but the casualties were unacceptable. Engineers were being killed faster than they could be replaced. By mid-June, American casualties were approaching the rates experienced in the worst trench fighting of World War I. The advance was measured in hundreds of yards. Entire divisions were being ground down. Replacements arrived from England, were committed to battle, and became casualties before they learned their squad mates' names. Officers began referring to the bocage fighting as the hedgerow hell. Men who had survived the beach landings looked at the endless succession of hedgerows stretching inland and saw only death. At the highest levels of command, the stalemate was approaching crisis. General Omar Bradley, commanding the 1st U.S. Army, was under intense pressure from Supreme Commander Eisenhower to break through and capture St. Lo, to expand the beachhead, to begin the breakout into central France. Bradley understood the tactical problem perfectly, but understanding it was not the same as solving it. His divisions were fighting as hard and as skillfully as any troops in any war, but the bocage negated every advantage the Americans possessed. Superiority in tanks meant nothing when the tanks could not maneuver. Superiority in artillery helped, but you cannot destroy what you cannot see. Air superiority was almost useless, the hedgerows concealing German positions from aircraft flying overhead. Research teams and engineering units worked frantically on solutions. Dozens of ideas were proposed and tested. Tank-mounted flails to beat through the vegetation, rotating cutters, bulldozer blades, flamethrowers, various types of reinforced rams. Each idea was tried, and each failed for different reasons. The flails got tangled in the roots. The cutters broke against the earth and stone. The bulldozer blades pushed the tank nose up, recreating the exposure problem. The flamethrowers set the vegetation on fire without clearing a path. The rams were too weak or made the tanks too heavy. Curtis Culin was not an engineer. He was not a scientist or an inventor. He was a 29-year-old sergeant from Cranford, New Jersey, serving as a tank commander in the 102nd Cavalry Reconnaissance Squadron. The 102nd was part of the New Jersey National Guard, citizen soldiers who had trained together before the war, crossed the Atlantic together, landed at Normandy together, and were now dying in the hedgerows together. Culin had joined the National Guard in 1938, 6 years before D-Day. His military service had been a part-time obligation, evening drills and weekend training exercises, until Pearl Harbor transformed the National Guard into the front line of America's army. He had trained on tanks for 3 years before seeing combat. That training had taught him how tanks were supposed to work in theory. The bocage was teaching him the gap between theory and reality. By late June 1944, Culin had spent 2 weeks watching men die in the hedgerows. He had watched infantry squads get cut down trying to cross the embankments. He had watched tanks get stuck, get shot, get burned. He had watched engineers blow gaps through hedgerows only to walk into concentrated enemy fire. He knew there had to be a better way, but the better way eluded everyone who tried to find it. The breakthrough came from observation rather than engineering expertise. Culin noticed that the problem was not the hedge vegetation itself, but the earthen embankment beneath it. The embankment's upward slope was what caused tanks to tilt nose up, exposing their bellies. If a tank could cut through the earth at the base of the hedgerow rather than climbing over it, the tank could stay level, keep its guns on target, and penetrate the hedgerow while remaining protected by its frontal armor. The concept was simple. The execution would require modifying the tanks with steel blades that could cut through earth and roots. Culin needed steel, heavy steel, strong enough to penetrate centuries-old root systems and earthen embankments that had stopped every previous attempt. The Germans provided the solution, though not intentionally. When preparing the Normandy beaches for the invasion they knew was coming, German engineers had planted thousands of steel obstacles along the beaches and in the surf zone. These obstacles, called Belgian gates and Czech hedgehogs, were built from heavy railroad steel and angle iron, designed to rip open the hulls of landing craft or stop tanks from advancing off the beaches. The D-Day invasion had pushed past these obstacles, leaving them littered across the beaches like steel debris. Culin organized a team to salvage the German beach obstacles. They cut the heavy steel into manageable sections using cutting torches and loaded the pieces onto trucks. Back at a makeshift workshop area, Culin and his team welded 4 steel prongs onto the front of a Sherman tank, creating what looked like steel tusks or horns projecting forward from the tank's bow. The prongs were angled slightly downward, positioned to strike the base of a hedgerow when the tank drove forward. The design was elegant in its simplicity. When the tank approached a hedgerow and the prongs struck the earthen embankment, the tank's forward momentum and 30-ton weight would drive the steel teeth into the base of the obstacle. The tank would plow forward, the prongs cutting through earth and roots like a massive plow. Instead of climbing up and over the hedgerow exposing its belly, the tank would drive straight through at ground level, its frontal armor protecting it, its guns able to fire forward throughout the approach and penetration. Cullen's first test was conducted in early July with a handful of officers and tankers watching. He climbed into his modified Sherman, started the engine, and drove toward a hedgerow that had stopped previous attempts. The steel prongs struck the embankment. The engine roared. The tracks bit into the ground. The tank plowed forward. Earth and vegetation exploded outward as the prongs cut through the root system and embankment. The tank burst through the hedgerow in a shower of dirt and shredded vegetation, remaining level, guns on target, emerging into the next field without exposing its vulnerable underside. The watching officers understood immediately that they were witnessing the solution to the Bocage stalemate. Word spread through the American divisions with the speed of desperate hope. Within days, Culin was demonstrating his device to General Bradley himself. Bradley grasped the significance instantly. This was not an incremental improvement. This was the breakthrough that would unlock the Bocage. He immediately ordered mass production of the hedge-cutting devices. Every available maintenance unit and workshop was mobilized to fabricate the steel cutters. The salvage operations on the beaches intensified, cutting torches working around the clock to reduce German beach obstacles into raw material for American ingenuity. The devices, quickly nicknamed Rhino tanks or Rhino attachments, were welded onto Sherman tanks by the hundreds. Ordnance units worked through late June and early July, modifying as many tanks as possible before the launch of Operation Cobra, the planned breakout offensive. The design was refined and simplified for mass production. Some versions used 4 prongs, others used 2 or 3. Some prongs were straight, others angled. Tank crews and maintenance personnel improvised variations based on available materials and specific needs. The essential principle remained constant. Steel teeth driven by tank weight and engine power would cut through the hedgerows at their base, allowing the tanks to penetrate without exposure. By the time Operation Cobra launched on July 25, 1944, approximately 60% of the tanks in First Army had been equipped with hedge-cutting devices. 3 out of every 5 Shermans now had steel tusks welded to their bows. The psychological impact on the tank crews was profound. Men who had dreaded approaching hedgerows now had a tool that worked. The Bocage, which had seemed an impenetrable death trap, had become penetrable. The tactical transformation was immediate and dramatic. Tanks equipped with Culin cutters could now approach hedgerows, punch through them, and emerge in the next field with guns firing. Tank infantry teams developed new tactics. The Rhino tank would drive directly at a hedgerow and smash through it while firing its machine guns to suppress defenders. Infantry would follow through the gap, clearing the field while the tank provided covering fire. The next hedgerow would be breached the same way. Progress accelerated from fields per week to fields per hour. The German defenders, who had relied on the hedgerows to channel and slow American attacks, found their defensive system collapsing. The hedgerows remained physical barriers, but they were no longer insurmountable obstacles. American armor was punching through them at will. German units that had successfully defended hedgerow positions for weeks suddenly found American tanks bursting through hedgerows they thought were impassable. Appearing in rear areas overrunning command posts and supply dumps, Operation Cobra succeeded in breaking the Normandy stalemate. The offensive, launched with massive air support and concentrated artillery, shattered the German defensive line. American armored divisions poured through the gap, racing into Brittany and central France. The hedgerow fighting that had characterized June and July gave way to mobile warfare in August. The Allied armies that had been stuck in the bocage for 2 months suddenly advanced hundreds of miles in weeks. Historians debate the precise impact of the Culin cutter on the Normandy breakout. Some argue that it was decisive, that without it the bocage stalemate would have continued for months, possibly endangering the entire campaign. Others suggest that its importance has been overstated, that American forces would have eventually broken through using accumulated combat experience and overwhelming force. The truth likely lies between these extremes. What is beyond dispute is that the Culin cutter provided American forces with a practical solution to a problem that had defied solution for 2 months. It restored mobility to American armor in terrain that had neutralized armor's effectiveness. It reduced casualties by allowing tanks to breach hedgerows without exposing their vulnerable undersides. It shortened the bocage fighting, saving time that would have been spent grinding through the hedgerows field by field. Whether decisive or merely important, the hedge-cutting device mattered. Curtis Culin was awarded the Legion of Merit for his innovation. The citation credited him with inventing a device that materially aided in the success of our breakout from the Normandy. Beachhead, he was promoted and received recognition from commanders who understood that battlefield innovation saves lives. After the war, Culin returned to Cranford, New Jersey, where he lived quietly until his death in 1963. His invention made headlines during the war, then faded from public memory as the war moved on to other battles and other innovations. The story of the Culin cutter embodies several themes that characterized American performance in World War II. First, the ability of ordinary soldiers to identify and solve tactical problems when those problems arose. Culin was not part of a research team or a technical service. He was a tank sergeant who saw a problem, conceived a solution, and improvised a device that worked. The American military culture, particularly in combat units, encouraged and rewarded this kind of practical problem-solving. Second, the willingness of senior commanders to adopt innovations that came from junior ranks. When Bradley saw Cullin's demonstration, he did not need weeks of study or layers of approval. He recognized a good idea, ordered its immediate implementation, and mobilized resources to make it happen quickly. The contrast with more rigid military cultures, where innovations required approval through chains of command and official testing, was stark. Third, the advantage of industrial capacity and material abundance. The Culin cutter required steel, welding equipment, skilled workers, and time. American forces had all of these in quantity. Maintenance units could fabricate hundreds of hedge-cutting devices because they had the tools, the materials, and the trained personnel. They could afford to experiment with different designs because failed versions were simply replaced with improved version. The Germans, operating with constrained resources and facing attacks on multiple fronts, could not have matched this kind of rapid, large-scale field modification even if they had conceived the idea. Fourth, the element of salvage and improvisation. Using German beach obstacles as raw material for American hedge cutters represented a practical form of poetic justice. The steel that was meant to stop the invasion was repurposed to help break through the hedgerows that threatened to stop the advance inland. This kind of salvage and repurposing characterized American logistics throughout the campaign. The technical specifications of the Culin cutter were deceptively simple. The standard design consisted of 4 steel prongs, each about 4 to 5 feet long, welded to a horizontal base plate that was in turn welded to the front of the tank. The prongs were made from German beach obstacle steel, typically angle iron or heavy steel bars. The spacing between prongs varied, but typically they were positioned to create maximum cutting effect across the width of the tank. The angle of the prongs was slightly downward, approximately 30 to 40 degrees from horizontal, optimized to dig into the base of the hedgerow rather than deflecting upward. The weight of the attachment was approximately 500 to 800 pounds, depending on design. This added weight had minimal impact on tank performance. The Sherman tank weighed approximately 33 tons fully loaded, so an additional half-ton represented less than 2% of total weight. The added weight was positioned at the front of the tank, which actually improved traction on the drive sprockets and helped drive the prongs into the ground when breaching obstacles. The cutting action relied on mechanical principles similar to a plow. When the prongs struck the earthen embankment, the forward momentum of the 33-ton tank drove the steel deep into the earth. The tank's 400 horsepower engine provided the power to maintain forward progress against the resistance of earth and roots. As the tank advanced, the prongs acted like massive chisels, breaking up the compacted earth and cutting through root systems. The forward motion and weight of the tank provided the force. The sharp steel prongs provided the cutting edges. Together, they could penetrate hedgerows that had been centuries in the making. The installation process was straightforward enough that tank crews and maintenance personnel could complete it in a few hours per tank. The base plate was welded directly to the tank's bow. The prongs were welded to the base plate. The welding required skilled operators because the welds had to withstand tremendous stress when the tank was plowing through hedgerows. Weak welds would fail, leaving the tank stuck in a hedgerow with prongs torn off. Ordnance units set up production lines, with each team specializing in particular aspects of the installation. Quality control was maintained by testing installations with trial runs against actual hedgerows. Variations on the basic design proliferated as different units improvised, based on available materials and specific needs. Some tanks received 2 heavy prongs instead of 4 lighter ones. Some designs incorporated serrated edges on the prongs to improve cutting action. Some units added horizontal crossbars between the prongs to prevent the tank from penetrating too deeply and getting stuck. British units developed their own versions, which they called prongs, using similar principles but different configurations. The tactical employment of Rhino tanks became increasingly sophisticated as crews gained experience. Tank commanders learned that speed and momentum mattered when breaching hedgerows. A tank approaching slowly would get bogged down, tracks spinning, prongs failing to penetrate. A tank approaching at speed would drive through with relative ease. The optimal approach speed was approximately 10 to 15 miles per hour, fast enough to maintain momentum, slow enough to remain controllable. Tank infantry coordination improved dramatically once the Rhino tanks proved their effectiveness. Infantry learned to move immediately behind the breaching tank, using the tank as a shield and entering the breached field through the gap the tank created. The tank would continue forward into the field, suppressing enemy positions with machine gun fire, while infantry would fan out to clear the corners and hedgerows where German defenders typically positioned themselves. This coordinated approach reduced casualties for both tankers and infantry while accelerating the pace of advance. The German response to the Rhino tanks was limited by the broader deterioration of their tactical position. By the time the hedge cutters appeared in large numbers, German forces in Normandy were already under severe pressure from multiple directions. They adapted by withdrawing from forward hedgerow positions more quickly, trying to avoid being trapped when American tanks could suddenly appear through hedgerows that had previously been barriers. German commanders also concentrated their Panzerfaust teams in areas where hedgerows channeled American tanks into predictable paths, attempting to ambush the rhinos at close range. These adaptations slowed but did not stop the American advance. The production numbers tell the story of rapid implementation. In the 3 weeks between early July and the launch of Operation Cobra on July 25th, ordnance units fabricated and installed hedge-cutting devices on approximately 500 tanks. This represented roughly 60% of the tanks in 7th Corps and parts of 8th Corps, the units that would lead the breakout offensive. The remaining 40% of tanks were either in positions where hedgerow fighting was less intense, or were unable to be modified in time due to maintenance backlog or lack of materials. After Operation Cobra succeeded in breaking the German line, the Rhino tanks proved useful beyond the bocage. Tank crews kept the prongs attached because they discovered additional benefits. The steel tusks provided some protection against Panzerfaust rockets, occasionally deflecting the shaped charge warheads before they could strike the tank's frontal armor. The prongs could be used to push aside obstacles in urban fighting, clearing roadblocks and debris. Some crews used them to tear down walls and fences. The devices remained in use through the remainder of the European campaign, though their primary purpose, breaching hedgerows, became less relevant once the fighting moved beyond Normandy. Curtis Culin's post-war life was quiet and unmarked by his wartime fame. He returned to Cranford, New Jersey and worked in various civilian jobs. He married and raised a family. He attended veteran reunions and occasionally spoke about the war, but he did not seek attention or publicity. Those who knew him described him as modest about his contribution, viewing the hedge cutter as a practical solution to a practical problem rather than as a major invention deserving special recognition. He died on November 20, 1963, at the age of 48 from health complications that may have been related to his military service. His funeral was attended by fellow veterans of the 102nd Cavalry Reconnaissance Squadron, men who had fought through the bocage alongside him. The local newspaper in Cranford published an obituary that mentioned his wartime service and his invention, but the story received little attention beyond the local community. By 1963, World War II was history, and the public's attention had moved on to other concerns. In the decades since, the Culin cutter has been remembered intermittently. Military historians studying the Normandy campaign have debated its importance. Museums have preserved examples of Rhino tanks. Veteran memoirs have included accounts of the hedge-cutting devices and their impact. The story has been told and retold in books and documentaries about D-Day and the Battle of Normandy. The essential truth remains clear. In June 1944, the Allied advance through Normandy was stalled by hedgerows that tanks could not penetrate without exposing themselves to enemy fire. A sergeant in the New Jersey National Guard conceived a simple solution: weld steel prongs to the front of tanks to cut through the hedgerows at ground level. The solution worked. Hundreds of tanks were modified. The stalemate was broken. The war moved forward. The story of the Culin cutter is not primarily about genius or heroism in the conventional sense. It is about practical problem-solving under pressure, about the ability of ordinary soldiers to adapt and innovate when confronted with unexpected challenges. It is about military organizations flexible enough to recognize and implement good ideas regardless of where they originate. It is about the material abundance that allowed rapid field modifications on a large scale. It is about the small innovations that accumulated together turned the tide of campaigns and wars. The hedgerows of Normandy remain today, largely unchanged from 1944. The fields are still enclosed by earthen embankments and vegetation. The lanes are still sunken and narrow. Modern visitors can walk the ground and understand immediately why the terrain was so difficult. What changed was not the terrain, but the tools available to fight in it. For that change, thousands of soldiers owed their lives to a sergeant from New Jersey who saw a problem and solved it with scrap steel and a welding torch.